Okay? The constant multiple rule. And again, this is kind of like the derivative of a constant rule. It's not really earth-shattering. There's nothing really exciting about it. Basically, it says, if I'm going to take the derivative of a constant, so say u as a function is a differentiable function, okay? And I want to take the derivative of some constant times u with respect to x. That's just equal to the constant times the derivative of u with respect to x. Okay? So for example, again, these are simple monomial examples. We'll get into something a little bit more complicated. But if I said f of x is equal to 7 times x to the 4th. In this case, my constant is 7, right? My differentiable function u is x to the 4th. So what this rule says is that this is just equal to, well, excuse me, the derivative is equal to 7 times, the derivative of this using the power rule now is 4 times x raised to the 4 minus 3 power. What's 4? 4 minus 1 power, sorry. 4 minus 1 power, which is 3. So I have 7 times 4, or 7 times 4 times x to the 3rd, which is the same thing as 28x to the 3rd. Now, you can start to get good at this and just say 4 times 7 is 28 raised to the 3rd. You're going to be able to make that jump straight from here to here. Okay? Rob?
In the denominator of that first equation, what's that thing next to x?
dx.
Okay.
Oh, that's a D? That changes everything.
Sorry.
All right.
Indeed. Indeed.
Rule number 4.
You didn't record that, did you?
Yes, I did.
Thanks, Bert.
Everybody's going to see it too, Margaret.
Rule number 4. Sum and difference rule. Okay. Sum and difference rule basically says let u and v be differentiable functions. Okay. So then if I'm going to take the derivative of u plus or minus v with respect to x, all that is the derivative of u with respect to x plus or minus the derivative of v with respect to x. Basically that says we can just line up a bunch of functions and add them or subtract them and just take the derivative of each individual function at a time. So this is an example. This is what allows us now to start working with polynomial functions. Before, all the examples I had done up here, they were all monomials, weren't they? Just one term. But now with this, rule basically says, if I give this as an example, f of x equals x cubed plus 6x squared minus 5/3 x plus 16. Okay? That's a cubic function, isn't it? Looks something like this. But if I take the derivative of this, the derivative is just going to be each individual term. So the derivative f prime of x is going to be 3x squared plus 12x minus 5/3, because 1 times negative 5/3 is negative 5/3, and then 1 minus 1 is 0. X to the 0 is 1. And then what's the derivative of 16? 0. So there's your derivative. Okay? That's basically what we've looked at, is just using the power rule and building these rules upon each other. Okay? I'm going to jump ahead to rule number 7.